Hello everybody, my name is Mariano Arcuri and I'm going to present climatically-induced depositional sequence in an underfilled lake, the Lower Cretaceous Rayoso Formation, Neuquen Basin, Argentina. My partners, Carlos Zavala, Mariano Meglio and Agustín Zorzano, we belong to G.C.S. Geological Services and also Universidad Nacional del Sur in Bahía Blanca, Argentina. Okay, the main objectives of this presentation are to analyze the cyclicity observed in the deposit of the Rayoso Formation at different scales, to discuss the factors that control the lake sedimentation as water balance, climate and subsidence, and finally discuss the sequence stratigraphy of this kind of underfilled lake and its impact on the distribution of source rocks and reservoirs. Okay, the Rayoso Formation is a well-known productive unit in Argentina. It is located in the upper part of the early Cretaceous. This unit can reach more than 1,000 meters in thickness, and it marks the final disconnection of the Neuquen Basin from the Pacific Ocean during the Barremian. We are going to see that in this unit we can recognize three fine-grained intervals, here, and here, with evaporitic rocks and some carbonates, and two clastic intervals, here and here. This led us to recognize three depositional sequences within this unit. A sequence that we call R1 here, or Rayoso 1. This first sequence is almost exclusively made up of fine-grained sediments, red and greenish shales, and some levels of evaporites, stromatolites, and limestones accumulated in a saline lake. Two other sequences, R2 and R3, composes of a sandy or lower clastic interval deposit in a lake of much lower salinity than the fine-grained intervals, succeeded by an interval of higher salinity and lower granulometry. We have for each of these sequences a transgressive system tract, which we call expansion system tract, and a regressive system tract or contraction system tract. We are going to see how these two types of system tract work and how this lake works. We know that during Barremian times exists a permanent lake with great change in its water balance. During periods when the basin received low sedimentary input and the water was more exposed to evaporation, then the lake tend to salinize and form fine and evaporate levels. When the lake received a greater amount of water and sediments, a transgressive effect was produced. The water increased its height, and at the same time important amount of clastic sand-type sediments enter into the basin. We are going to see that these sands are the main reservoir of the unit, while the fines material constitute regional seals. We know that these fines intervals were accumulated within a saline lake body because we have a content of palynomorph, charophytes, some foraminifera and stromatolite that indicates a permanent saline water body. If we go to the internal organization or to the sequence stratigraphy of the Rayoso Formation, we see these cycles here. We have the sequence R1, in which the level of the lake falls as a result of decreasing the river discharges, and we have the development of these evaporates and some stromatolites. In sequence R2 and R3, we have a transgressive interval characterized by the input of important amount of water and sediments in this time, in transgression. We are going to see the advance of the lake until at a certain moment we go to the restriction periods here. It is in the contact between this regressive and transgressive system track we have the sequence boundaries. If we go to a regional scale, there is an important angular unconformity to the top of the Rayoso Formation, and its limit with the Neuquen group here, where it's a very low angle truncation appear. That regional unconformity will make disappear a large part of our R3 sequence. This is a regional, this and this are a regional cut for more than 100 kilometers from south to north. Now, if we go to the sequence stratigraphy, we are going to see that internally each of these system tracks, the transgressive system or expansion system track and the regressive or contraction system track, have particular internal cyclicity. In these cycles, important volumes of water and sediment enter to the system. These important volumes of sediments are ordered according to the related to the magnitude of the floods. These floods result in delta system possible of littoral run type, and internally underwater delta system where we have channels and lobes related to hyperpigment flows. On the other hand, during contraction system track or regressive system track, the lake fluctuates between oligomictic and meromictic periods or conditions. In meromictic conditions, here we have the basal part of the lake that is salt saturated and the upper part is not saturated in such a way that we can have superficial concentration of salt that drains of crystal toward the bottom, or sometimes the development of stromatolitic levels. During oligomictic conditions, the entire lake is saturated in such a way that we have chemical precipitation and we have significant levels of anhydrides. Combining these oligomictic and meromictic periods, there are periods where there is a greater inflow of fresh water, and we are going to see it reflected in the accumulation of fine materials of reddish to grayish or greenish shales. These cycles are well ordered, giving us this dilution condition when some times of delta enter or sometimes of very localized delta are generated. Meromictic condition, oligomictic condition of the total saturation of the water body. Now we are going to analyze more deeply these cycles. For expansion system track or transgressive system track, we are going to see the contribution of significant volumes of sands. In the field, the amount of sand is the first thing that catches your attention, and the grain size of these sands. Those sand grains are fine and very well sorted. It's important to say that conglomerates or levels thicker than fine sand are not recognized in the Rayoso Formation. This is basically since during periods of construction or regressive periods, when the lake loses a considerable area towards the margin of the lake, during those arid periods, important aeolian systems are settled down, as we see here. These aeolian systems are capable to maturate these sands and produce a significant volume of fine sands. These fine sands, once the climate gets more humid and there is more water available, are eroded and transferred to a deeper part of the basin. So during this expansion period, these fine-grained sands, previously maturated in an aeolian environment, travel through rivers, systems, and enter to the lake as hyperpigment system within the development of channels and lobes in the deepest part of the lake. This behavior of the lake in these periods is transgressive due to the progressive rise in the lake level. Hyperpigment flows deposit that we recognize within the Rayoso Formation were produced as a result of river discharge with higher density than the receiving water body. These discharges are composed of a mixture of fresh water and sediment, which give it a density greater than that of the body of water, the receiving body water. In this case, the receiving water body was a brackish type. Because of its high density, littoral deltas are not formed. We don't have the typical marine delta or coastal delta or givel deltas. Rather, the flow sinks in the coastal zone and travels basinward, carrying channels and accumulating in channels and lobes. Now we are going to analyze the configuration of these sedimentary bodies of channels and lobes. The channels are covered over previous lobes and construct as they advance product of flows called shed flows. These flows, as they advance, produce a frontal lobe that is channelized as the flow advances. And once the flow decreases in concentration and volume, these same channel areas can be filled with the same type of deposits, giving us a particular type of configuration and lobe system. Here we see an outcrop of a sublacustrine channel of the Rayoso Formation, where the lateral accretion surfaces can be clearly seen. It is a channel that somehow resembles a meandering fluvial channel, but unlike river channels where there is basically moving water, in these channels that we have is a mixture of water and sediment, which makes at the same time lateral migration and vertical gradation. You can see clearly these steps that represent the lateral migration of the channels. Here it's clear one step. Regarding its facies, we are going to see that in proximal or higher energy zones we can have bedload facies with clay-clast conglomerates, fine sand with cross stratification, and sand level with aligned clast. In the innermost area, or when the flow lost its capacity, we will have mainly massive sands or laminated sands, or with claiming ripples, which is the claiming ripples are the most common structure within the Rayoso Formation. As it is a freshwater lake or brackish lake, we do not have enough density to produce the flotation inversion, or what is known as lofting, as occurs in marine system. In low salinity system, lofting does not normally occur. Here we see the main types of facies: sand with cross bedding or subhorizontal bedding with clay clast, laminated sands, massive sands, or with dome or hammocks. In particular, these sands where we see fluctuation in sedimentary structure, which are indicating variation in concentration and flow velocity. These possibly are indicating long duration flows or quasi-steady flow and variation in their speed and concentration. Something particular about this variation in the speed and concentration of the flow we can see from a gradual change between the different sedimentary structures. Among these deposits, as we see here, they have massive sands with class indicating bedload, levels of massive sands that alternate with laminated sands, or in this case, laminated sands that alternate with claiming ripple sands. This variation in flow velocity have different products depending on where we are in the system. In proximal zones, there can be variation between massive sand and sand with clast, as we see here. In more internal areas, massive sands that alternate with laminated sand, and in more distal area we have this laminated sand that alternate with clay-mill ripples. Each of these facies changes suggests fluctuation in flow competition, change or fluctuation in the rate of sedimentation, as in this case, and finally change or fluctuation in the velocity of the flow. All these variations give us a fairly complex environment where the resulting facies are also complex. If we want to analyze how it works the whole system, we are going to see that as flow evolves, erosion and deposition zones migrate in such a way that in a complete cycle we can have the same grain size from proximal areas to distal areas in what we call forward and backward cycles, or forward-stepping, backstepping cycles. Here, for example, we are talking about a system that progresses over a sequence boundary with system of channels and lobes that extend toward the innermost zone of the basin with a transgression. As it is said, expansion or transgressive system track. Finally, upwards, when the lake loses its volume and dimension, we go to a saline lake together with the regressive system track with coastal delta system and marginal aeolian systems. These aeolian deposits will be the most coastal subaerial part of the saline lake. In this drone video, we can see the Rayoso Formation, as you can see in the field. This locality is called Agrio del Medio. This unit is characterized by its color bands. Rayoso means in Spanish striped or with strips. Therefore, the name of this unit, which is taken from its type locality at the Rayoso Hill, what you can see here, you can see the lower part that corresponds to the R1 sequence, a construction system track, and on top of this you see these red sands that correspond to the lower part of R2 sequence, which is considered the expansion system track or transgressive system track. Okay, now we are going to analyze the contraction system track. In the contraction system track, we have these internal areas here where we are going to have meromictic to oligomictic lakes and marginal delta systems. These small deltas that are advancing from periodically transport fine reddish sediments, marginal aeolian system, which are the main factory for the sand that are going to be introduced into the basin later. All these elements are combined with a lake with a very important phreatic input. The phreatic contribution is proposed as the main source of the salts that we are going to have later. In this case, you can see alite cubes or these anhydride sulfide salts that we are going to have within the basin with a chicken wire type structure or even stromatolitic levels. Here we see how it works, the deposition in meromictic and oligomictic periods, and also during dilution events. In meromictic periods, we have a saturated zone here and a zone with low saturation. The salt concentration occurs on the surface of the body of the lake. Once the crystals are of sufficient size, they precipitate to the bottom, and if they can get past the unsaturated zone, they can bottom out and start to grow as single crystals. In oligomictic periods, the entire body of water is saturated. Therefore, crystals that form on the surface easily reach the bottom where they can grow. Finally, during these dilution periods, the lower one here, we can have the input through this deltaic system of some clastic levels and marginal deltaic systems. These are the cycles that we can find in from meromictic to oligomictic and to dilution period. Here we have another drawn video just to show you an excellent example of how contraction system track looks like in the field. We call this locality Barda Larga, and in this amazing arc it is possible to walk on the same bed for more than 2 kilometers. It is clear the cyclicity in the deposition. Red beds and sandstone represent the dilution periods, and stromatolite, limestone and andesite deposited. Maybe here it's difficult to distinguish, but in the field it's easy to identify that meromictic and oligomictic periods. Okay, just finishing some of the understanding or conclusion that we can draw from the Rayoso Formation. What first draws our attention is that the sequence stratigraphy of the lake system is very different with respect to the marine basins. While in marine we speak of low sea level with sediment contribution or low stand, in lake system we say that the sediment contribution occurs during transgressions. Regressive or contraction system tracks of lacustrine system are normally fine-grained. In these periods where there is little input of water and sediment, the lake tends to decrease in size. We are going to see that the low stand deposits are mainly evaporitic, on the contrary to a marine low stand. Sedimentary input occurs mainly during transgressive periods. Hyperpigment flows are very important, mainly since in a low salinity lake it is very easy to pass the threshold required for flow to sink in the coastal zone and continue to form channels and lofts in internal area of the lake. Finally, there is a marked climatic control in the depositional cycles, which will give us a stacking control mainly by this large change in the water balance. Thank you.